I'd like to thank my co-authors, Dr. Presti from Germany and Dr. Frank Tay from Dental School in Georgia. Dr. Cumberland, who's here, will be able to answer some of the question if there is about this molecule I'm going to be talking about. And then Dr. Schrader from the Emory University and Professor Gerhard Kruger, who's a visiting professor at Texas Department of Pathology and the former dean of the School of Medicine in Cologne University in Germany. These are the two structures which you will see, you are seeing it here. The first one is quaternary ammonium compound, and which is the is Dow Corney's as shown here, and this was is the precursor of the K21. K21 was developed by Dr. Cumberland in 2011. But prior to the K21, he also had another molecule, K18. The K18 and the K21, when he developed them, he found that it had the antibacterial activity. As you can see it here, this is the K21 showing its spectrum of the bacteria on which this have been tested there. And most of the bacteria which we tested there, gram-positive and negative, and these are the ones which are resistant to the antibiotics there, and including the tuberculosis and Klebsiella, which is one of the most common strain resistant to the drugs we are working at in a group in Zambia, where it is causes a high mortality in the neonates. And it is also, you can see it, it also works on the fungi. So the K18, when we developed it, and the idea was, beside the bacteria, whether this will have an effect on the viruses. And we chose to work on the viruses which are orally transmitted, and also some which are in the nasal cavity. And the viruses we chose to work that time were the enveloped viruses of herpes simplex 1, human herpes virus 6, and human herpes virus 7. And we also have the RNA virus of influenza A. And then we also chose the RNA virus, that is the norovirus, which is the unenveloped, and also the polio. For polio, we use the surrogate of polio, and that's the MS2 phage. The material, the K21, what we have been able to dissolve in two different ways. In fact, three ways we tried it. One, we are dissolving it in the acetone and then to the water. The second we did was directly going from the alcohol, 50% alcohol where it is, and then we're dissolving into the water. And the third one, we also were able to do it putting in the ethyl glycol and dissolving that one there. Now, when we dissolve in the acetone, it has some milky appearance, but if you heat it, then it is okay, it disappears, and it still have its antimicrobial activity. The RNA viruses which we were testing it, we use the procedure, this is which are described by the EPA for the germicidal, disinfectant, and hand sanitizers. So here is the short way. What they do with you do is when you receive the compound and they have these viruses on the titrate part, and then these steps are taken there, which are shown in the next slide. More you can look at it. That is that we take the glass surface, the petri dish on which the virus is put down, it dried, and then on that one, then your compound is sprayed, and the maximum time they allow it that way is the 10 minutes. And then after that, it is neutralized, and after that they titrate, and then they tell you how much it is inhibited. This is the EPA approved method which they are using it here. So this is the method here described in this slide. And the passing criteria, according to them, is that they will see that it is that the inhibition is very significant, and also the toxicity should be less than 3 logs, the way they have described it. So the testing for the RNA viruses, according to this, were done at an antimicrobial lab, which does this thing in Texas for us. This slide, I showed it yesterday also. As you can see, that the new nomenclature of the herpes viruses describe them. There are 9 herpes viruses now. And the group of the beta herpes viruses, now you have the cytomegalovirus, and then you have the Rosola viruses, which are 6, 7 are there, A and B. And then you have the beta herpes viruses there, and then the gamma herpes viruses are described there. The cytotoxicity of the K21, the human foreskin, fibroblasts, most of our assays were done for simplex. They were done in the Vero cells. That's the African kidney cells, monkey kidney cells. However, we also wanted to know whether the dose we are using it is not toxic to the normal cell, and that is your foreskin cells. So we tested it, and here you can see the CC50 is being given a 9.4 millimicron. So first thing we looked at was the K21 inhibits the HSV1 entry into the Vero cell there. The way we are doing it, that we do the inhibition of the HSV1 by taking the K21 and we expose for 3 minutes, and then those cells, they are allowed to culture for 30 minutes. After that, those cells are taken. One part of the cells, they are trypsinized, and the other ones, they are not trypsinized, their cell. And the DNA is extracted from it, and then we do the quantitative PCR. So data you are seeing it is on the quantitative pore, where you can see the CC50 is 8.5 millimolar. Sorry. Here again, while we did when we were doing the plaque assay, which had normally been done with the herpes simplex, most of the work people have done it, tested it here. And so the dose which we chose it to work with was not toxic to the cells there, and we also tested the not only the K21, but also tested the acetone and the alcohol, which was still left when we were having the test done there. So the plaque assay slide to see will the effect of the K21 on the infectious HSV1 progeny, and we infected the vero cells as well as the human foreskin cells in the presence and the absence of the K21, and then taken the lysate of these cells and did the second round infection, and we formed the plaques, and they were counted, and then that gave us the inhibition result. Here it shows is the flow cytometry method described here, where we are seeing it that we measured the cytotoxicity that rises cause of the HSV1 infection. HSV1 infection kills the host cells faster the infection cycle. K21 prevents this cell death because of the inhibition. So this is what you are seeing it in this slide here. And the next slide, what we also looked at it, what effect it has on the various proteins, major proteins of the HSV1. So in this one you can see that we are measuring the various protein. We looked at the Western blot there, and we see the inhibition there, as you can see what is being done there. And so here again we show that the major protein which we use the to do the Western blotting, and they were inhibited by the presence of the K21. So the results for the HSV1, it shows that it was inhibiting the entry of the virus, as well as we saw that if you have the infectious virus there, and the K21 will prevent the infection of the HSV1. And the dilution, which was the most concentration of the K21 we used, which was working and not toxin inhibiting, was 0.025%, and there it was not toxic. Now HSV6, as I showed yesterday in my presentation, this is a Eucharist virus, and now the primary infection causes erosiola, and that is the subatum in the babies, and also it is common. There are two forms of it, A and B, as I showed in the nomenclature slide, and B is the one which causes the roseola, and A, we have not seen much of the anything which we see with the A1, sometimes there are seizures we see fever, but not the rash which you normally see with the B. So the effect of the inhibition of HSV6A, we tested it, and the cell we used is the HSV2 cells, which is a continuous cell line. It's an immature T cells there, and that you see in this slide, you can see it on the CPE which is there, and we are using the cherry protein, and in infected cell you can see is that the and the cell control cells which are infected, and the one which are treated with the K21, and there is a very good a killing of those cells there. Then also you can look at this slide. We are also doing that. We did the cell. We took those cells and extracted the DNA and did the PCR, and to show the quantitative difference, and there's the inhibition on there. And the third thing which we also in this, like the HSV1, we also look at the effect of this one, and on the you can see the we have the P41. We had tested that one, and we see the inhibition there, and the control, as you can see, is the actin being used as the control. Same thing we did the similar to the HHV6A, and we did the similar experiment, but here we use the SUPT1 cell, which are the cell, again, SUPT1 cell have the CD4 receptor, and the HHV7 infects these cells and produce the cytopathic effect, as I showed it yesterday in my slide there. So the SUPT1 cells are also, they go, so the cells are infected, then we mix those cells with the normal cells, and after that, those cells, you will see that in the presence of the K21, those cells were dying much faster than we see when there's no K21 there. And here we also see that one of the gene U27, and there was a very significant effect of the K21 as we use the control there. Now for the RNA viruses, this slide shows which are the RNA viruses we chose to work with. And the first one, you're showing that we use the feline norovirus. Now, noroviruses are also called the caliciviruses, and they cause diarrhea, and they have epidemic infections, very common with these, and so they're widespread from that point of view. And so we use the feline norovirus, and the strain which we got from is the ATCC strain there. For the influenza A, we use the H1N1 strain, and this is widespread, and I don't have to talk about much about influenza because today there were too many, they can tell how big problem the influenza A is. And when for the polio, we use the phage MS2, and the host cell for growing is the E. coli. So we were growing them in the E. coli, and now I will show you first. And as I already described the procedure, how it was done there. The K21 inhibits the in vitro replication of the influenza A virus. So you see here that we use the strain of ATCC VR1736. Now, original virus titer we showed in the log was 5.80, and then the virus which was inhibited by the 0.025% of the K21 is 4.10 log, and the one which was not inhibited, which was retarded after the neutralization assay was done, was 1.70, and the control of the K21 we want to see the effect. It shows there was only 0.20 log inhibition. So it was not really much any effect of the the controls there. And so the conclusion of this was that 0.025% of the K21 was able to inhibit the influenza A virus. According to that, their inhibition was close to 98%. That's what, according to the assay they did, they showed it to us. So this concentration was not toxic, and acetone and the alcohol had no effect on the cells, and so the cells were doing pretty well. And as I said, the assay was performed according to the EPA methodology, which they have. The second one, for the phage, we use the K21, which we have diluted in the ethanol glycol. And this graph which you are seeing, it shows there the first, the virus titer. The second two, there, are you seeing there are the two concentration of the K21 which we used, and at 1 to 10 and 1 to 100. So there were 99% inhibition there, you're seeing it. But on the other hand, we also saw that the ethylene glycol itself was also inhibiting. And you can see almost about 45% inhibition with ethylene glycol at 1 to 10 dilution, but also then when we looked at 1 to 100, there was still a little bit, but at 1 to 1,000, there were no inhibition. So ethylene glycol itself is an antiviral. And obviously, so the K21, as we can see there, and the log in there, the titer was 4.0 and 2%. Here we use the K21 at 1 to 10, 1 to 100 dilution was greater or equal to 3.15, and but the control of the ethylene glycol, there we showed at 1 to 10 was 2.54, 1 to 100 0.4, and 1 to 1,000 0.15. So ethylene glycol, we don't think we would like to use it because it also has, but it could be useful when there is a more high toxicity of the K21 that we could use to dilute it and in the presence of the K21, which will reduce the toxicity and will enhance the antiviral effect. So the effect of the K21 in vitro inhibition on the feline neurovirus. So here you're seeing the two experiments done there. The first experiments which we did was the 0.025% concentration, and the second was 0.1%. So if you look at the first one, and basically there is no inhibition. And in the second experiment, there is 94.38% inhibition. However, what we also noticed was that this concentration of the K21 was somewhat toxic to the cells there. So what we are seeing it here is that the people who did the experiment first with the quat, they were saying is that if you take the quat and put it onto the plastic and the glass surface. And then you see the degeneration of the virus. They saw with the envelope virus, the degeneration started within 24 hours, and it went to 5 days, and then it slowed down, and then it went on, and there was a complete decay. However, with the polio virus they used for that same way as the envelope virus, there were no decay, basically less than a log. So there quad was showing the effect in the sense that the envelope viruses, they are okay. You can use it, it will inhibit. But when they are using the non-envelope viruses, and it was going down. So my results here show is, as I show, that we were able to show the inhibition, but it varied with the concentration we used there, and also shows that it is less K21 is required to inhibit the enveloped viruses than compared to the non-enveloped viruses. The conclusions are that the quad having practically no virucidal effect on non-enveloped viruses like polio, K21 showed significant inhibitory virucidal effect both with the polio virus and the norovirus. K21 reduced the influenza virus, and so did the herpes simplex 1, HHV6A, and HHV7. So these studies, but that were also showing that there was when we are using the 0.1%, there was effect, cytotoxic effect, when the other one was not. What is the application at present we have is the K21. We can use it as a germicidal or sensitive for hand sanitizer or as a disinfectant. And one very interesting thing which we noted was that if we take the K21 and apply onto the blisters, which are due to herpes simplex 1, they disappear in 72 hours, and there's no pain. Thank you.